Hi, here's Malban again. And guess what? I'm going to talk about Vide, Vectrex Integrated Development Environment. This time around I would like to talk about YM files and what you can do in or with them in Vide. There are two ways to access YM files from the editor or from utilities menu itself. This time I will go there from Vide, the editor, but you can also access YM files directly from the utilities menu. So Vide, and I will do a new project so we can sort things out. YM test. Certainly I'll put that in the projects directory again and create, and it's empty. So for demonstration purposes, I'll add a YM file that I did some time ago. This is Frogger in-game part 1 theme. I created from MAME, the multiple occurred machine emulator, and I will use this file as an example. To access the YM editor, you place your mouse cursor above the YM file, right mouse button, and build Vectrex YM. So we do that here, and this is the actual YM editor. You can listen to the music if you just do a play. So a little bit. As you can see, this is the original Frogger tune from the arcade machine I extracted using MAME. I'll stop that and I will show you the differences between the compression algorithms that I supply. So you can always create source code from the YM file, either with a player or without a player. For now I will just leave the creation of the player on so we can actually see what we are doing in the emulator. There are 4 different compression settings for the moment. And once you press create source, the selected kind of source will be created. Perhaps I should talk a little bit about the complete editor first. So, where do they start? Start usually by loading a YM file. You can do that with this button. If you do not come from Vide, load YM file. I'll do that for the show just now. I go to directory above. Here you see all my Frogger files I extracted. I load another one, play it. As you see, this is another jingle, and all information that is known about the YM file within the headers is displayed here. It's a YM version, attributes, frequency, future data. I've never seen anything but 0 here. Name, author, comments, and so on. These are all informations which are included in the header of the representing YM file. You can choose the speed. Usually it's 50 Hz, but there are some YM files with 60 Hz. There's 2 different formats of YM, of how YM file saves the data. It's interleaved or non-interleaved. The editor can handle both, but usually the default format is interleaved. In this area over here, the complete YM data is displayed. YM files, if you don't know, are actually registered data from the PSG, the sound chip, register 0 to 15, where 14 and 15 are input-output registers. They are usually not very interesting. They do not have to do anything to do with music or sound generation, so you usually leave them out. Then there are 3 voices, 3 channels within the PSG chip. The first 2 registers is the frequency of the first channel, then the second channel, then the third channel. The register 6 is a noise frequency. Register 7 is an enable register. Here you can enable either tone or noise for the 3 channels. It's bit coded. then the amplitude for the different channels, and last and nearly least, there is a envelope, coarse and fine-tune register, and you can choose an envelope. Not really very many YM files use these envelope settings. For the creation for Vectrex or for the data, you can also choose which registers you actually want to use. There are these checkboxes. The default setting is that the upper 5 registers are left out, but you can choose that as you want. You can play the files, and if you switch on a register or off, this play routine does respect that. So if I switch these two off, well, it does play, but the volume is not changed anymore, so the amplitude is always kept to 6 and 3 in this case, and well, so on. In these little colored text boxes over here, the current played YM file, YM line is displayed. In opposition to that, below here, the actual data that is represented in the PSG chip is displayed. When playing a file, this is usually the same, but if you you can manually place the data you enter here into the sound chip. For example, if I, for whatever reason, put a 0F in here, and if I double click now that checkbox, text box, then the 0F is transported to the PSG chip. If the register is enabled or disabled, I can so manually set the PSG registers. There's also the possibility to change the current YM data. The table is actually editable, so you can choose your YM data as you go along. When playing, the actual playing data is displayed also in these, or what I call visual representation. The amplitude registers are little sliders, and the frequency actually represent notes. Not all frequencies, not all possible settings represent actual notes, but the frequencies which do represent can also be displayed as notes above in these little combo boxes. So you can, for example, also choose this combo box C1, then the actual data is put into the frequency registers below and to the corresponding line you'd selected in the YM file. If you want to edit YM files yourself, you can do that manually. This is tedious and I do not recommend it, but sometimes it might be necessary, or well, you can add individual lines to your YM file using the plus button. Still have to edit them. Load the file again so we have actually something to see. This is a Frogger coin jingle. You can also cut lines with these cut tools. You can paste the lines again, and you can not only cut, you can also copy lines. You can insert a YM file into this YM file. Just choose one and it gets inserted, and you can write the selection that you chose as a different YM file. Actually, I think I never used that, but maybe someone might find that useful. There is a lister tab over here. Here all YM files are listed from the location that you last loaded the YM file from. So if I load again, you see there are quite a couple of YM files in the current directory, and these files are also displayed here, and with a double click you can play these files. As you can see, these are all Frogger jingles. So then I load a, well, I've got the shortcut, might as well use it. I load a jingle again, as you may or may not see if you watch the complete YM file. You see that for this coin, for example, only channel 1, channel A is used. So I might as well switch all other channels off, and no noise is used. So it sounds exactly the same if I switch all of these off. Single channel YM files can also be represented by AYFX files. So you can save actually the data of one channel to these in this format, in the AYFX. Okay, I probably will use some short form of that. Anyway, channel 1 I can save to this format, press save, and what was it? Coin was it? No? Coin. Save it. Now you can load the AYFX file again. Wherever I saved it, there it is. Coin AFX, and play it again. Once. The advantage of these files are they are channel independent. So if I just want to play the coin in a different channel, I can do that. I clear everything, and now I want to place the data in the channel B or channel C. I just have to load it for the other channel, and you can do that on the Vectrex side also. The format of the saved data does not include any channel information, only frequency, amplitude, and so on. So okay, this was some YM stuff, and now I will come to what I originally mentioned right at the beginning of this video, the differences between the encodings. I load the file again that I wanted to work with right from the beginning. Where, oh, now it's complicated. We go here again. Build YM file. So just for the show, uncompressed data. I create a source and I create a player. The source is now inserted into our project. This main file will be our new main file. I can compile it and run it. The Frogger theme actually is quite soft for one reason or another. I think because it's a background song of the original game, only amplitudes 1 to 8 are used, and it goes up 1 bit position higher, so it's always very low. You see the main file for each of the generated data will look nearly the same. There's always a little main file, then there's actual data of the YM and the player. The data in this case is quite large because it's unpacked. Here you can see the original YM file, more or less all registers one after another. The actual file size of the resulting binary is quite large. It's 11K, so for this little tune no packing was done and 11K already used. The player itself, it's quite short because the only thing that is done, player there, is take all registers and shuffle them to the PSG sound chip. Okay, let's try the next one. We go to our theme again, and YM sound historic. Create player. This actually takes a little bit time usually. With this little program it was quite fast. We can look at the main, there you will see YM player is now loaded, the rest is nearly the same. You can also play it. As you listen, there's not much of a difference, but if you look at the size of the file, it's 1/10 nearly as the size of the old of the previous one. But the play routine is the slowest. I can show you with Tracky. You can look at Tracky, and there we can watch how many cycles are actually used for playing. You don't have to be afraid. The actual player does not take all that much time as is shown here. There's a string displayed here, and the string display always takes huge amounts of cycles. The string which is displayed is empty, but nonetheless it takes its time. So usually with a YM file there's some sort of title. The name over here is displayed alongside, but there's no title for our Frogger theme. You can look at the data. This is the name. The first character is a 80, so it's an empty name, but the routine is called nonetheless. So if I just leave out these string printing, it's probably much faster. Here you can see this is more or less the actual sound routine. It averaged out at about 2080, but it has peaks up to 8000. I'll do for comparison the uncompressed one and play that again. Unpack, yes. It's again with the string. So, speed comparison. This routine is by far the fastest, 1751 cycles, although this can even still be faster, as you can see right now. With it, this is a file data. We only use 2 channels. You can leave out all the other channels and they won't be transported to the PSG. That again will be faster. So, third version. This is a YM sound optimized speed. Create source. And here we go to the main file again. Frogger in-game pathy, YM player, and we leave out the print string again and play it. Reset. Here you see the routine a little bit faster than the old YM historic. They average about 2200, but peaks are usually quite a bit lower. Now it does not usually. And the last is a streamed player, create source. One thing I forgot, the YM sound optimized speed length, the binary file is about 1800, so it's a little bit larger than the historic YM sound. Now, streamed version. Create it. Look at the main file. Still called, can't be actually, stream player. Now it's correct. And I haven't got any string printing here, so we do not have to leave that out. So this is again faster. It averages about 2000, or I guess it will go up to 500, 2500, and the average play speed is about 1300. So this is In this case, actually the fastest playing routine. It's even faster than uncompressed, at least in average, but it maximizes at 2500 approximately. So this is actually quite fast and usable even in tight situations. But again, the resulting binary file is larger. It's about double or triple the size of the packed YM files. So depending on the situations where you want to use YM files, you have to choose the player you want, depending on how much space and how much time, respectively cycles, you've got left. Well, that was about it that I was going to tell you today. So have fun with it, and goodbye.